Welcome to today's class of chapter 10, that is practical geometry. In this chapter, we shall learn about some basic geometrical concepts which would help us gain more information about the geometrical shapes and its properties. Here, let us start with the fundamental geometrical concepts. Fundamental geometrical concepts are the ones that help us in solving the geometry problems more efficiently. And these concepts include points, line, plane, line segments, and ray. Well, now let us understand these concepts one by one in detail. And so we'll start with point. A small dot marked by a pencil on a sheet of paper or a prick made by a fine needle on a paper are examples of a point. A point determines a location. It has no length, breadth, or thickness. Here, the figure shows 2 points A and B. Further, we will learn about line. The basic concept of a line is its straightness, and it extends indefinitely in both the directions. Here in the figure, we can see a line having two arrows in opposite direction, which indicates that it extends indefinitely. Line has length but no breadth or thickness. It has no endpoints and is made up of infinite number of points. Next, we shall learn about plane. The basic concept of plane is its flatness, and it extends indefinitely in all directions. The length and breadth of a plane are unlimited, which means plane has length and breadth but no thickness. The figure by the side shows plane. Further, we shall learn about line segments. The portion of a line between the points is called line segment. Also, two or more line segments are called equal if and only if they have same length. And they are called parallel only if line containing them are parallel. Here, the figure by side shows an example of line segment AB having M as its midpoint. Now, let us learn about ray. A ray has only one endpoint and has unlimited length. An unlimited number of rays can be drawn with a given initial point. Two rays with same initial points and extending indefinitely in opposite directions are called opposite rays. Here, now let us learn about triangles based on sides and angles. Well, let us first start with triangles based on sides. Equilateral triangle. Well, in equilateral triangle, all the three sides are equal in measure. Isosceles triangle. For isosceles triangle, we can say that two sides have equal measure. Scalene triangle. In scalene triangle, all three sides have different measures. Next, we will learn about triangles based on angles. Acute angled triangle. Here, all the angles measure less than 90 degree. Obtuse angled triangle. Here, one angle is greater than 90 degree. Right angled triangle. Here, one angle is 90 degree. We shall learn about the properties of triangles. Well, the exterior angle is equal to the sum of interior opposite angles. Also, the sum of all the interior angles is 180 degree. Here, sum of the lengths of any two sides is greater than the length of the third side. And at last, we will learn about the Pythagoras theorem. In any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And this can be seen here in the figure given by the side. That b square plus a square is equals to c square. Further, we will learn as in how to construct a triangle with SSS criterion with the help of an example of triangle ABC where AB is 4.5 cm, BC is 5 cm and AC is 6 cm. Well, here SSS criterion means side 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 criterion. So to begin with, we will first of all make a rough sketch of the triangle and then we'll start with the construction based on this sketch. Step number 1. We'll draw the line segment BC of length 5 cm. Step number 2. With B as center, we'll draw an arc of radius 4.5 cm. Step number 3. Now, with C as center, we will draw an arc of radius 6 cm. Next, we'll mark a point A on the point of intersection of the arcs and then join AB and AC. Thus, we can say that the required triangle ABC can so be constructed. Further, let us learn as in how to construct triangle with side angle side criterion with the help of an example of triangle PQR where QR is 7.5 cm, PQ is 5 cm and angle Q is 60 degree. Here SAS means side angle side criterion. In this construction as well, we will draw the rough sketch first and then we'll start accordingly. Thus, to begin with, we'll draw the line segment QR of length 7.5 cm. Next, at Q, we will draw QX making 60 degree with QR. Now, with Q as center, we will draw an arc of radius 5 cm and this arc would cut QX at P. At the end, we would join PR and thus we can say that the triangle PQR required can so be constructed. Also, let us learn how to construct triangle with ASA criterion with the help of an example of triangle XYZ where angle X is 30 degree, angle Y is 100 degree and XY is equals to 5.8 cm. Here ASA criterion means angle side angle criterion. For this, we will also draw a rough sketch of the triangle required and then we'll start accordingly. Thus, we'll follow the following steps of construction in order to construct the required triangle XYZ. Draw XY of length 5.8 cm. Now, at X, draw a ray XP making an angle of 30 degree with AB. Further, at Y, draw a ray YQ making an angle of 100 degree with XY. Here, the point of intersection of two rays can be named as Z. Thus, this is how the triangle XYZ that we required can be constructed. Further, let us also learn how to construct triangle with the RHS criterion with the help of an example of triangle LMN where angle M is 90 degree, MN is 8 cm and LN is 10 cm. Here we will draw a rough sketch of the required triangle and then act accordingly. Here we will follow the following steps of construction in order to get the required triangle. Here first of all we will draw MN of length 8 cm. Next at M we will draw perpendicular to M and name it as MX. Further, with N as center we will draw an arc of radius 10 cm to cut MX at L. And at last we will join LN. and thus this is how the triangle LMN can be constructed. Well, I hope you are clear with the concepts. Thank you.